So we're going to do some more examples of verifying. Okay. We start off with this one and we have to pick a side. And I think that the left-hand side is more complicated, so I'm going to start with it. Now the first thing I know is that in the right there's only cosines. So using one side to guide the other tells me that I should turn the sine squared into cosines, and I can do that using the Pythagorean theorem identity. Okay. Now, I notice there's no squareds over here and there are here, which kind of leads me to believe I might want to try factoring and canceling. Sometimes it's a little hard to factor when they look like this. So ignoring the cosines, this is what we're trying to factor. Okay, so the bottom is a difference of squares. That's what the Pythagorean theorem identity pieces always turn into. And the top factors like this. Then of course we have a factor that cancels, and I end up with my desired right-hand side. So be very careful to pay attention to if something will factor or not. All right, for our next example. I would like to verify this. Now this one is interesting because both sides are fairly complicated, but I don't have sines or cosines on either side, so the trig functions are complicated on either side. But the fact that this side has the factor squared means I'm going to work with the left-hand side. So the first thing I'm going to do is actually FOIL that out. Okay. Now, if you remember, we have the reciprocal identity that says that cotangent is 1 over tangent. And that means that if I multiply them together, I just get 1 by the reciprocal identity. Okay, so now I have tangent squared x minus 2 plus cotangent squared x plus 4. Okay, well obviously I can combine the number portion, and I'm left with this. Now you may be stuck here until you remember that we're going to use one side to guide the other. I want to end up with secants and cosecants. And we happen to have identities that will turn a tangent into a secant and a cotangent into a cosecant. Namely, the other two Pythagorean identities. Okay, so using those, we know that tangent squared is secant squared x minus 1. And cotangent squared is cosecant squared x minus 1. The minus 1s and the plus 2 cancel, leaving just secant squared plus cosecant squared as we wanted. Okay. One last example. Now, quite clearly, we want to work with the right-hand side. It has the factors, and it has a more complicated angle. Okay, I'm going to go ahead and FOIL it. Sine squared x over 2 minus twice sine cosine plus cosine squared. Now, anytime we have a sine squared plus a cosine squared, and the angle inside them is the same, the Pythagorean identity says it equals 1. So comparing this to what we want tells us that I need to turn this into sine of x, okay? And I go looking for something like this and I say it looks an awful lot like the double angle identity with one change. In double angle, it was 2x here and x here. But double angle holds true as long as the angle here is twice the angles there. So by the double angle identity, this is 1 minus sine x, which is what we wanted. So even though you might not have to memorize the identities, it is very helpful to know what they look like and to be familiar with them so that you can spot them when you are trying to verify identities.